Okay, welcome. So what I want to do is do another live stream here for Irrational Zeros of Polynomials. This was not a planned live stream, so I just want to get into it. I see that I have a little bit of time to work on the live stream, so I was like, you know what, let's just go and get this, settled away here. This is a homework assignment that I gave to my students, and they have a test coming up, so I was like, you know what, let's get this through. So I don't have a lot of time because I got to go and head out there, so I'm not sure if I'll have time for questions. I guess we'll kind of just see how quickly I can work through this document or this homework. So what you can see here is we're just going to work on finding the zeros, focusing on irrational zeros, but finding the zeros factoring. We're going to look at finding all of the zeros when given a factor or when given a zero. We'll look into finding the zeros, writing the equation when given the zeros. And then also, last but not least, we'll look into some multiple choice questions. So in between from the free response to the multiple choice, I'll just take a little break and check with you guys. Hey, Peter. Hey, Mr. Wright. Thanks for you guys joining in. And I just want to get right into it. If you guys do have some questions or anything else that you want me to answer, feel free to add it to the chat. And again, if I have some time at the end, I am a little restricted on time here. I wasn't really planning on going live at this time. But if you guys do have some questions, I'll be more than happy to add it in there. So. All right, without further ado, I am going to get started here. So finding the zeros and multiplicity of the following polynomials by writing the linear factorizations. And it's being a little slow. Hopefully that's not going to impact my stream here, so we'll see this. We'll see how we write. All right, so finding the zeros, again, guys, remember we're looking into basically setting our function equal to 0. And then now what we're going to be doing is, looking in for different factoring techniques. And the first factoring technique we always want to look into is see what we can factor out that they have in common. And you can see that these two terms have an x squared in common. So what I'm going to do is factor out an x squared. By factoring out an x squared, I'm left with an x squared minus 5. All right, now for this first one, I'm going to use the zero product property, but after that, hopefully you will kind of get this idea. So we can use the zero product property, so x squared is equal to 0, and then x squared minus 5 is equal to 0. Okay, and then obviously to go ahead and solve for x, we're going to want to add 5 to both sides. And therefore, we get x squared is equal to 5. To undo the square root, we are going to, to undo squaring, we're going to take the square root to both sides. And just remember that we can't take the square root of 5. We can't simplify it. So therefore, we're going to have x equals plus or minus the square root of 5. So remember, when we introduce the square root, we have to make sure that we are keeping the positive and the negative version. Here, I'll just do square root with that. And we don't need to use plus or minus for 0 here because 0 is not positive or negative. So what we have here is, so we have the zeros. Let's go ahead and write the linear factorization of this polynomial, and then we'll talk about the zeros. So the linear factorization here. Now, I'm going to write this x squared as a linear factor, so it'd be x minus 0 squared. And then these two factors, you could write this. You can see how these are your two zeros. So we can write them as factors. Another way you can think of it, this is a difference of two squares, right? It's x minus the square root of 5 and x plus the square root of 5. So this can be written as x minus the square root of 5 and x plus the square root of 5. And another way to think about that is if you were going to use like the zero product property from here, when you'd set these each equal to 0, you would go ahead and solve. You get x equals 5 and x equals negative 5, which are two solutions there. So therefore, our zeros now is, you can see here, the 0 is actually the number 0, but that has a multiplicity of 2 because the power of the factor, the power of this linear factor is 2. Now, sometimes we don't write it as x minus 0. We just leave it as the squared. But the main thing is I don't want you to be confused of this having a multiplicity of 2 and then saying this has a multiplicity of 2. That's why I write it into this linear factor format. So you can see it's really a linear factor raised to the second power. It just gets simplified to x squared. Whereas this one, is not simplified to linear. So when we factor this down to x minus square root of 5, x minus x plus square root of 5, you can see that the zeros are both going to have plus or minus square root of 5, and they both have a multiplicity of 1. Okay, and what I told my students, if I'm not writing the multiplicity, then we will assume that it's going to be at 1, or I will assume it will be 1. All right, next example, you can see I can factor out a 2, so that's going to be the first thing I'm going to do. So I'll just replace this equal to 0. And by factoring out a 2 here, oops, I must have made a mistake. That should be a squared. So by factoring out a 2, that's going to be a x to the 4th minus 3x squared Nope, yep, plus 1. Okay, now we want to see if we can further factor this down, and I made a mistake. Dang it. I don't know what I was planning on doing. Let's see here. What was I looking into doing here? I made a mistake because that's not the right answer. Because you can obviously see this is not factorable. You can't factor out the 2 from out there. So that's not going to be factorable. Now, if I did place this with a 4, then that would work. So x minus 2, yeah, that's must be what I needed. So sorry about that. We're going to change that to a 4. So what that means is this will be a 2. And I didn't have time to work on this. I've been kind of a little busy getting everything caught up. So what that means is I haven't had time to go back through my homework and check all of the answers. But I quickly noticed this mistake here. And now what I can do is I can factor this down. Again, treat this like a quadratic, right? Treat this like a quadratic trinomial where you're factoring the trinomial, but you're just going to raise the powers. So what two numbers multiply to give you 2, add to give you negative 3? And for right now, I'm just going to do, well, that's going to be x minus 2 and x minus 1. And then if I just wanted to, x times x gives me x squared, and I need this to give me x to the 4th. So I'm just going to raise the powers here. Okay. Now the next thing is it comes down to the zero product property, and you can look at this as using the zero product property. And the problem is a lot of times people come in with this 2 and they don't know what to do with it. Well, it doesn't matter. Like if you use the zero product property, I'll actually use this in blue here. If you use the zero product property, like x squared minus 2, like put that in parentheses. What you notice is the first step you're going to do is divide by 2 anyways. So this factor 2 doesn't really matter. It doesn't affect the zeros. But I'm going to kind of skip ahead a little bit quicker. Rather than, setting these each equal to 0 and then solving, I'm just going to factor them across irrational numbers. So here's a difference of 2 squares. You can factor this across, rational numbers. X squared minus 1, difference of 2 squares. X minus 1, x plus 1. And what we already notice here is just like this, x squared minus 2 can be factored down like I did over here. X minus the square root of 2, x plus the square root of 2. So the linear factorization is just going to be x minus the square root of 2 times x plus the square root of 2 times x minus 1 times x plus 1. And then from here, I can determine the zeros, which is just going to be plus or minus the square root of 2 and plus or minus the square, not square root, and plus or minus 1. And then to determine the multiplicity, we're just looking at the power of each of these factors, and we notice that the power of each of these factors is 1. So we'll just leave it at that. All right, last example here, or at least in the factoring, is g of x is equal to x to the 4th minus 4x squared minus 2x plus 8. So we notice that this has 4 terms, so we're not going to use the same factoring technique. In this technique, we're going to want to use grouping. So I'm going to group the first 2 terms and the last 2 terms. And basically what I'm going to do here is now look into factoring out the greatest common factor of each of these grouping terms. So the greatest common factor of x to the 4th and 4x squared, it looks like it's just going to be an x squared. When I factor out an x squared, I'm going to be left with x squared. This is not right. This is supposed to be a cube. Man, I messed this all up. I typed this really bad. I'm sorry for that. So when I factor out an x squared, that should be an x cubed. That's what happens when you create your documents too quick. So that should be an x cubed. That should be an x. So that's x, and then that's going to be minus 4. Okay, and then over here, what we want to do is factor out a term so that we can obtain x minus 4. So you can see here they both have a negative. Like if I factor out a negative 2, that's going to leave me with a x minus 4. Now we have 2 more kind of expressions here separated by subtraction. So now what I'm going to want to do is factor out the GCF as well between these 2 expressions, and you can see that common factor is x minus 4. And that leaves me with the remainder of x squared minus 2, which I could use a zero product property, but we already factored this down, right? So let's just go ahead and factor this down here to x minus the square root of 2 times x plus the square root of 2. Okay, and therefore you can see here we have 3 zeros, and they all have a multiplicity of 1. So we have 4, and then plus or minus the square root of 2. Boom. All right, so now let's go ahead and move on to the next problem. So what do we do when we are trying to find all the zeros, but we're given a factor? And you can see in this case, we're given a factor that is irrational. So the one thing that I mentioned that we talked about today in class was when you're given a factor, especially irrational, remember the conjugate is going to exist. So therefore, we also know that x minus the square root of 3 is also a factor. Now, remember, factors multiply to give you a product. Like 3 times 4 is equal to 12, right? However, not all factors multiply. For instance, 2 and 3 are both factors of 12, but 2 times 3 does not equal 12. And so what I notice here is this times this does not give me my polynomial. So what that means is there exists another polynomial that we can multiply by these two to give us that. So what that means is if I multiply these two, like 2 and 3, which gives you 6, you can still divide that term into 12. So if I multiply these two, I can still divide that into this to find that unknown factor, right? Because basically, if we were going to write the linear factorization, we know that this times something else is going to give us that. So to do my division, what I'm going to do is I'm going to multiply this x plus square root of 3, x minus square root of 3. And if you kind of recognize the patterns here, going from negative square root of 5, positive square root of 5, and write them in here, you can see that this factor is x squared minus 3. If you were to factor that out, you would see you'd get those two. So now what I'm going to do is I'm going to use long division with that factor. In my computer, oh, I know why it's getting so slow. I got to type in the power cable. Hold on a second. Let me make sure. I hope I provided my power cable. I hope I didn't leave that at home. Uh-oh. That's not good. I think I left my power cable at home, so... So this live stream might be... Oh, no, there it is. Sweet. All right. Sorry about that for the live stream. I just... when my battery starts to... Or my computer starts getting really slow, I can see that my battery is, starting to die. And I was like, man, what is going on with that? And that's because it doesn't have its power source. It's a little bit older of a laptop, 2013 MacBook Pro, so but it still holds its own. I mean, I give it a lot of juice. I mean, it does a lot of my videos and everything like that. So either way, still works out pretty good. So I will continue. Hey, Diana, happy you can help. Hi, Carlos. Hey, ask the question in the chat. I'll get to it in a second. I'm about to take a break. But I want to go ahead and finish this long division here. So let's go ahead and set this up. So I have x squared minus 3, and I'm going to divide that, much faster, into x to the 4th plus 4x cubed minus 12x minus 9. All right. So x squared divides into x to the 4th, x squared times. Remember, you multiply the x squared times both terms. X squared times x squared is x to the 4th. Not x to the 4th. Just said it and I didn't write it. X squared times negative 3 is a negative 3x squared. Did I not write that? Okay. So I don't have anything to subtract the negative 3x squared from, so I'm just going to put it in between there. Negative 3x squared. So now we go ahead and subtract our rows. And you can see there's nothing to subtract here, so these are going to... I'm going to bring this down, so therefore I have a 4x cubed, a negative, actually that's going to be a minus a negative, so therefore it's going to be a positive 3x squared, minus a 12x, and minus a 9. So these terms I'm just going to be bringing down. All right, now let's do it again. X squared divides into 4x cubed, a positive 4 times. 4 times x squared is... 4 times x cubed, sorry. Oh, that's a 4. That goes into their 4x times. Jeez. 4x times x squared is going to be a 4x cubed. And 4x times negative 3 is going to be a negative 12x. Okay? So then again, we're going to subtract the rows. I have nothing to subtract these. You can see that these subtract give you 0, these subtract give you 0, so we're basically bringing down a 3x squared, and we're bringing down a negative 9. Okay, let's do this one last time. X squared divides into 3x squared, a positive 3 times. 3 times x squared is 3x squared, and 3 times negative 3 is a negative 9. So when I subtract these rows, you guys can see we get a remainder of 0. So what that means is this mystery that I was multiplying by is x squared plus 4x plus 3. Now, you can see I have factor, factor, factor. These multiply to give me my f of x. These are equal to my f of x. So I can set these all equal to 0 to find the zeros. Well, here, these are easy to find the zeros, right? Set each of these factors equal to 0, you can find the zeros. So the only factor that I haven't really finished yet is this one, 4x plus 3, equal to 0. Well, this one's easily factorable. That's x plus 3 times x plus 1. Now, what else did my directions say? It just said find all the zeros. So my zeros, I'm going to kind of skip ahead because I'm going to use the zero product property and solve. So therefore, you can say your zeros are going to be plus or minus the square root of 3, negative 3, and negative 1. Okay, because again, I'm using the zero product property from here. All right, in the next example, I have a 0, and when you have a 0 and it's a rational 0, usually it's typically preferred to use synthetic division. I don't like using synthetic division with irrational terms. You can do it, but it's not as convenient, I think, as using it when you have rational terms. So in this case, remember, we're going to set up synthetic division. So synthetic division, you take your 0 on the outside, and you kind of have like an inverted long division symbol, and then you're just going to take the coefficients of your dividend. So instead of writing the whole thing down below, you're just going to take the coefficients. So we have negative 2, negative 1, 2, and 1. And again, this is a 0, so once we apply division, we got to make sure we have a remainder of 0. So we see we've got a remainder of 0, so that worked. All right, so remember synthetic division, first term you always bring down, that's your freebie. So we have negative 2 times negative 1, so you multiply on the diagonals, is going to be a positive 2. Add on the verticals, negative 1 plus 2 is 1. 1 times negative 2 is negative 1. 2 plus negative 1 is 1. 1 times negative 1 is 1 times negative 1 is negative 1. We get a remainder of 0. Now, just to remember from synthetic division, that is your remainder, which is good. This is your coefficient of your constant, or coefficient of x to the 0, which is 1. We have our coefficient of our x squared, of our linear, and then our coefficient of our x squared. Now again, remember the quotient is another factor, right? If something divides into something else, like if 3 divides into 12, it divides into 12 so many times, which the answer is 4. So this, negative 1 divides into, like this as the factor, which would be x plus 1, divides into this polynomial, this quotient number of times, which is negative 2 x squared plus x plus 1 equal to 0. Okay, now if we wanted to, now we want to see if this is factorable or not. Well, the first thing, I want to get rid of this negative, right? I don't want to be dealing with this negative. So I'm going to factor out the negative, so that would give me a positive 2x squared minus x minus 1 equals 0. And now I can just divide out the negative 1 on both sides, get rid of it. So therefore, I'm left with a 2x squared minus x, not a minus multiplying, sorry, minus x minus 1 equals 0. Okay, and if this is factorable, that means we can break this down into a set of 2 binomials. So this would be 2x times x equals 0. And 2 numbers that are going to multiply to give me negative 2, add to give me 1. And I think I'm seeing this. This would be a, do I have any rational? I didn't pick any rational 0. That's kind of weird. So this one would be x times, let's see, if I did, no, that'd be, yeah, x minus 2, and then plus 1. So let's just double check our work. 2x times x is 2x squared. 1 times negative 2, oh, that doesn't work, so it'd have to be a 1, yeah. No, stop. So that'd be a 1. So 2x times negative 1 is, or 2x times x is 2x. 1 times negative 1 is negative 1. 2x times x is positive 2x. Okay, so that's not working. So I'm seeing this is not going to work because there's not going to give me a negative 2x. Oh, that's negative 2x, and that's positive 2x. Yeah, that works. Right? It works. What if you're incorrect? If you are incorrect and you can't factor it, you should use the quadratic formula, which is confusing me because my goal was to choose a problem that was non-factorable. So that's why I'm like, what did I do here? I wanted to choose a problem that would have given me something that was non-factorable, but it was late last night and I don't really remember what I was thinking. So I could have actually done one that is non-factorial. Now, we could always default to the quadratic formula, and obviously if you're checked, but I'm just checking these. Like 2x times x is, remember, you can always check your factoring. 2x squared, 2x times negative 1 is negative 2x, 1 times x is positive x, and 1 times 1 is negative 1. And you can see here that combines to give you exactly what our result is. So I didn't include a irrational zero in this example, so I guess I messed up last night. Still the problems are fine. There's nothing wrong with it. It just doesn't have any irrational zeros. So now I can set each of these factors equal to 0. So x in this case is negative 1/2. And then I have x minus 1 as my other factor, so therefore x equals 1. So my zeros are going to be x equals negative 1/2, x equals positive 1, and you can see here is x equals negative 1. There you go. And you have 3 zeros, power 3. Works out very good. Could you upload videos about integration? Okay, so last but not least, guys, I'm going to go and take a break. Oh, man, I'm running out of time. So write the following equation given the zeros and the multiplicity. I'll get to your seconds, guys, or get to your questions right after I'm done with these two equations. So just remember, guys, when you're trying to find you're trying to write the equations, just set each zero equal to x. Now remember, if the positive square root exists, then the negative square root has to exist. And then obviously we have x equals negative 1/2, and then that's going to have a multiplicity of 2, which I'll get to in a second. Now remember, if you kind of noticed our patterns here, like here's the factors, here's the zeros. So if all we want to do is write the zeros, you're basically just setting it equal to 0. If you're going from negative 1/2, you can see that that factor is 2x plus 1. Basically what you do is you multiply by 2 on both sides and then add the 1, right? See, look at it, I already did this problem. Multiply by 2 on both sides, add the 1. You don't want to add the 1/2. So what I have here is I can say, I'll just write y equals x minus, so if I subtracted that over, there'd be x minus 2 radical 2 times x plus 2 radical 2 times a 2x plus 1, and then remember the multiplicity is to the second power, so that's squared. Now, you got to multiply this by the difference of two squares. So remember, you can see here that's one's positive, one's negative, so that's going to produce a difference of two squares. So x times x is x squared. Negative 2 square root of 2 times positive 2 square root of 2 is going to be a negative 4 times 2, which is a negative 8. So I have x squared minus 8. And again, guys, if you want to work it out by FOIL, then do it by FOIL. Here's a perfect square trinomial, so you should know that that's going to give you 4x squared plus 4x plus 1. Okay? Now, for the sake of time, actually, you know what? Whatever. We got it. Screw it. I'm just going to multiply this going out. And for this, I'm going to use the box method. I was going to say you can just leave it in your factored form, but you know what? Let's just multiply it out. So I'm going to use box method just to kind of keep things organized. I don't mind distributed property, but I can see that I just make mistakes when I use distributed property. It's hard to keep things together. So what I'm going to do is I'm just going to find the area of this box by finding the area of all the little rectangles. So therefore I have 4x to the 4th, 4x cubed, x squared, negative 32x squared. Here I'm going to have a negative 32x, and here I have a negative 8. And what you can see here is I do have some like terms. I have an x squared and an x squared. So therefore my final equation would be y equals 4x to the 4th. Hate that. 4x to the 4th plus 4x cubed. And then you can see x squared and the negative 32. So that's going to be minus 31x squared minus 32x minus 8. Okay, so the next example, we're going to do the same thing, but this one kind of comes into a little caveat here. You can see we have this we can see this have this, term with the real solution as well as the irrational part, right? So same kind of thing. You're going to set this equal to x. So x equals 1 minus the square root of 3. And if we were going to set this equal to 0, it'd be x minus 1 plus the square root of 3. And that would be your factor, right? It's basically just like the reversed operations of the 0. And that's something that we've the pattern that we've noticed. Please remember, guys, if 1 minus square root of 3 exists, then 1 plus square root of 3 needs to exist. So the only difference is you're still going to be, the other factor would be x, x minus 1 minus the square root of 3. Okay, and then we also have a 0 raised to the third power. So my equation here is going to look like this. I'm just going to write x to the third because that will give me a 0 of 0. And then I have this lovely thing, x minus 1 plus the square root of 3 times x minus 1 minus the square root of 3. Now, to make this go simpler, I'm going to use a shortcut. You could do the box method here with the 3 columns and 3 rows, and there's nothing wrong with that. What I'm going to do is I'm going to use some pattern recognition and recognize that the first 2 terms are exactly the same. So really what I have here is if I multiply these, I have a difference of 2 squares again. I have x minus 1 times x minus 1 the same, square root of 3 and square root of 3 the same, but positive and negative. So when I go ahead and multiply this out, I get x minus 1 squared, and then square root of 3 times negative square root of 3 is going to be just minus 3. Now, I can multiply out x minus 1 squared because that's going to be a binomial squared, or a perfect square trinomial, which would be a x squared minus 2x plus 1, and then minus 3. And now, guys, I'm just going to distribute the x cubed and then do 1 minus 3. So I have y equals x to the 5th, and then minus 2x to the 4th, and then 1 minus 3 is negative 2. Negative 2 times x cubed is negative 2x cubed. And boom, there you go. All right, let's go and take a quick little break. I do got to kind of move on, so I am not going to be able to take any questions, but I do kind of see some of you guys. Hey, Mohammed. Hey, Charlene. Hey, Kirby Wood. Take a break and try again. I'm not sure what you're imagining. Imaginary quadratics. Either way, can you do calculus? Yes, Dinah, if you look at my channel, I have I'm not teaching calculus this year, but the last 2 years I taught calculus, calculus AB. So I have a whole bunch of videos. They're all organized into the chapters. So I would definitely go and take a look at them. Hey, Captain Gaming, glad you can come in here. And Cotton Candy, I am sorry. I would love to be able to handle your question. Basically 64 to the 1/3 power, what you'd want to do is see if you can write a number to the 3rd power, which really quickly, actually, I can do this real quickly. If you have 64 to the 1/3, think about a number raised to the 3rd power. Well, 2 to the 3rd power is 8, 3 to the 3rd power is 27, but 4 to the 3rd power is 64. So you replace 64 with 4 cubed to the 1/3. Now use the rules of exponents and you multiply the powers and you're just left with 4. So anyways, didn't have time to go through that, but hopefully that helped you out. All right, let's go ahead and finish this off, guys, because I do have to run. I apologize for that. But again, I do believe I will be going live here possibly on Thursday again with the other homework for complex zeros. So in this one, it's just looking for us to use the quadratic formula. So before you can do it, you got to make sure it's set equal to 0. So 0 equals 2x squared plus 10x plus 1. So I got to get everything to the same side. Now, what I'm going to do is I'm going to determine the discriminant, which you guys can see is actually 23, it looks like, for all of them. But they don't have everything on the same. So that's kind of interesting. So let's actually just write it out. So it's opposite of b, so that's negative 10, plus or minus the square root of 10 squared, which is 100, minus 4 times a, which is 8, times 4 times a times c. So 4 times 2, which is 8, times 1. That's going to be 92. 23. I guess that would be 4, right? And then that's going to be all divided by, so that would be 92. So let's actually write that in there. 92, all divided by 2 times a, which is 4. Okay, so immediately I'm seeing this 5 halves. Now I want to see which one. So if I was to simplify this, the 5 over 2, I'm going to get 5 halves. Now I just want to see what does the square root of 92 divide to? Well, if you see 23, right, and then 23, you can see that's going to be 46. So you can see that I can rewrite the square root of 92 as 4 times the square root of 23. So therefore, I can really write this as negative 10 plus or minus 2 square root of 23 over 4. And then if I was to divide everything by 2, I would have negative 5 plus or minus, so the answer is B. The next example is write the cubic function given the zeros. So again, I have these zeros. I know that that's going to give me x plus the square root of 2 times x minus the square root of 2 times x plus 4. Those are going to be the factors, basically just the opposite sign. So therefore, I'd have, when I multiply these out, I'd have x squared, not plus, x squared minus 2 times x plus 4. All right, so now I guess I need to multiply it out. I'm not sure. They're all giving me negative 8 as the final term. So let's do this. So let's just do distributive property. X squared times x is x cubed. X squared times 4 is 4x squared. So that's a positive, so therefore that one doesn't work. Negative 2 times x is a negative 2x. That one doesn't work. And negative 2 times 4 is a negative 8. So you can see here the last one standing is C. Oh, I guess I could have divided those out. Either way. Number 3 says find the remainder when f of x is divided by x minus k. So in this example, what we're going to do is use the remainder theorem. So again, remember the remainder theorem is if you plug in the 0 f of k, that's going to give you the remainder. So they're saying k is negative 2, so all I'm going to do is just plug in f of negative 2. So f of negative 2 in this case is 2 times negative 2 cubed minus 8 times negative 2 squared minus 3 times negative 2 plus 13. Let's see what we get here. So that becomes a negative 8, so that's a negative 16. This becomes a positive 4 times a negative 8, so that's a negative 32. This is a positive 6, and then plus 13. So let's see here. We get, in this case, I'm getting a 19. 19 plus negative 16 would be a positive 3, and then positive 3 plus 32 is going to be a negative 29. Looks like the answer is D. Number 4 says, which of the following statements is R equivalent to x plus 5 as a factor of a polynomial? So if you know x plus 5 is a factor of a polynomial, then we know that, remember, if x plus 5 is a factor, then you can set your factors equal to 0, and you could find the 0. So x equals negative 5. Well, x equals negative 5 is 0. That is correct. Negative 5 prime 0 is a x-intercept. Yes, real zeros are x-intercepts. X equals 5 is not a solution. You can see the solution is negative 5. So that one doesn't work. So the answers are 2 and 3. And last but not least here is what is the remainder when same thing is divided by x minus 3? So again, we're going to want to use the remainder theorem. Just remember this is the factor. So therefore the 0 is positive 3. So in this case, now we're going to do the exact same thing, but we're going to do p of 3. And that's going to be 3 to the 4th plus 3 cubed minus 3 squared minus 2. 3 to the 4th, so 3 cubed is 27, that's 54, that's 81. So 81 plus 27 minus 9 minus 2. And I can see here that adding 81 plus 27, even if I subtract 9 and 2, is not going to be anything here, so that is going to be none of these. I didn't have any challenge problems for that, but I do got to run. I do appreciate you guys joining in on the live stream. And sorry, guys, I wasn't able to answer any of your questions for this, but I I will be back later on Thursday, and hopefully I'll have a little bit more time here that I can answer your questions. So I just wanted to make a quick little live stream to get this homework out so I can get it on to for my students, so therefore they have something to check out. And hopefully, it's helped you guys out as far as doing a little bit of long division, a little multiplying, little synthetic division, a little bit of factoring, kind of covered everything. So it was kind of nice to help you guys out with that. And again, in Thursday, we will cover complex zeros and in preparation for our tests. So until next time, guys, thanks so much again for showing up, and I'll see you guys on the next stream.